Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS 3301 Data Structures. The unit is list. In this video, we are going to discuss about doubly linked list. A doubly linked list is or two-way linked list is a more complex type of linked list which contain a pointer to the next as well as a previous node in the sequence. Therefore, it consists of three parts. First one is the data, then second one is a pointer to the next node, then and a pointer to the previous node. Is shown in figure. This is a representation of the doubly linked list. The structure of the doubly linked list is at first the struct node, that is the pointer for the previous node, then integer, the data to be declared in integer data part. Then next one is a struct node, that means a pointer to the next node. The previous field of the first node and the next field of the last node will contain null value. The previous field is used to store the address of the previous preceding node, which enables us to reverse the list of the backward direction. Then doubly linked list calls for more space per node and more expensive basic operations. Inserting a new node in a doubly linked list, there are four cases. First one is a new node is inserted at the beginning, then second one is a new node is inserted at the end, then the third one is a new node is inserted after a given node, then fourth case is the new node is inserted before a given node. At first, the new node is inserted at the beginning. In this is the algorithm. At first, we check whether the memory is available for the new node. If it is available, that memory is exhausted, then overflow message is printed. Otherwise, the memory is available, then we allocate the space for the new node. Then after that, set its data part with the given value, and the next part is initialized with the address of the first node of the list, which is stored in the start. Now, since new node is added as the first node of the list, it will now be known at the start node. That is, the start pointer variable will now hold the value, that means the address of the new node. The next one is the new node is inserted after the at the end. Here the same procedure for the beginning insertion at the beginning. In here we will take the pointer variable and initialize it with the start. After that, in the while loop, we will traverse through a linked list to reach the last node. Once we reach the last node, in the step name, we can change the next pointer to the last node to store the address of the node. Remember that the next field of the new node contains the null, and which signifies the end of the linked list. The previous field of the new node will be set to so that it points to the node pointed by the pointer. Then next case is the new node is inserted after a given node. This is also same as in the single linked list. Here we take the pointer variable and initialize it at the start. The pointer now points to the first node of the linked list. In the while loop, we can traverse through the linked list, which is equal to the particular number. After this, the new node will be inserted after the particular this node. Once we will reach this node, we can change the next and previous field in such way a new node is inserted and this. The next case is the new node is inserted before the. This is same as the previous case, but in the previous case, we are using the given the after location, here the before location. So the previous fields in such way the new node is inserted before the desired node. Then next one is the deleting a node from the doubly linked list. These are the same four cases. First one is the first node is deleted, then second one is the last node is deleted, then third one is a node after a given node is deleted, then fourth case is a node before a given node is deleted. In the first case, this is the algorithm to delete the first node. At first we check the linked list exists or not. Suppose if it is in the start equal to null, then it signifies there are no nodes in the list and the control is transferred to the last statement of the algorithm. However, if there are the nodes in the linked list, then we can use a temporary pointer variable pointer that is set to the pointer to the first node of the list. For this, we initialize pointer with the start that store the address of the first node of the list. In the step 3, start is made to point to the next node in sequence, and finally the memory occupied to the pointer is freed and returned to the free pool. Then this is the same procedure for last node. This is the algorithm. Here the pointer now points to the first node of the linked list. With the while loop traverses through the each of the last node to reach the last node. Once we reach the last node, we can access the second last node by taking the address from the previous node of the field. To delete the last node, we simply have set to the next field of the second last to the null, so that it now becomes a last node to the linked list. The memory of the previous last node is freed and returned to the free pool. The next case is that the node after a given node is deleted. We want to delete the node that is given. In the here the same procedure, but in a small case is different. We take the pointer variable pointer and initialize the start value. The pointer variable now points to the first node of the doubly linked list. The while loop traverses through the linked list to reach a given node. Once we reach the node containing variable, the node is succeeding. It can be easily accessed by using the address stored in the next field. The next field of the given node is said to maintain a contents in the next field of the succeeding node. Finally, the memory of node succeeding the given node is freed and returned to the free pool. This is same as for the node before a given node is deleted. This is the algorithm for the procedure. Here the while loop traverses through the linked list to reach the desired node. Once we reach the node containing value, then the previous field of the pointer is said to contain the address of the preceding field, which comes before pointer. The memory of the node preceding pointer is freed and returned to the free pool. Thank you.